Hi, 1324 students. We are moving into talking about probabilities and statistics, right? So in section 8.3, you're introduced to the notion of probability, and you're expected to instantly be able to use your information that you organized, the statistics you organized using a Venn diagram, for answering questions about probability. So there's some key points where you need to know some rules, like the words and or are reserved terms and have very special meaning. Okay, so so we're kind of doing this branching over from talking about sets and using set notation to talking about probabilities. So I'm using that example that we had before about using a Venn diagram with 3 circles and keeping the same counts, the same populations, cardinalities of these sets, using that, right? So if we want to talk about a probability of something, we need to have defined an experiment, okay? So a probability, you can't even get started unless you have defined, well-defined, what is the experiment? So suppose that we are looking at the set of all social media users. That's our universal set. When we're talking about probabilities, that might get referred to as our sample space, okay? And the experiment is that we are going to randomly pick one of those social media users and ask them what platform they have used in the past month. Okay, so the possible outcomes, anytime there's an experiment, there should be outcomes. So the outcomes we're looking for here that we're going to label are that, say the social media user randomly picked used Facebook this month. Or they use Instagram, or they use TikTok. Okay, so they could respond with just one of those, or 2, or all 3, as we have seen, right? So these outcomes are considered elements of the sample space. So members of that big, large set, universal set. And then what we do is we define events. So this is a list of the events we're going to be discussing here. So events are subsets of the universal set. Again, that also gets called the sample space in probability terms. So let's let A be the set of all those users who said yes, they've used Facebook this month. B, be all the users who said they used Instagram this month, and C, all those who said they used TikTok this month. All right? And then we can talk about probability using this definition here. The definition of a probability of an event, okay? Which really is a subset of your set of all possible outcomes. That probability is the ratio of the cardinality of that subset over the cardinality of the whole sample space or the whole universal set. That ratio is defined when A is a subset of the universal set, okay? So for example here, the probability of A, well, we've randomly chosen a social media user and they answered that they had used Facebook this month. That would be equal to the cardinality of the set A, okay, is all these users of Facebook, whether they're only using Facebook or Facebook and Instagram or Facebook and TikTok or all 3, right? All those belong to that. So we would find this probability by taking 1.97 plus 0.28 plus 0.17 plus 0.03, okay, and dividing it by the cardinality of the universal set, which here is 3.8. Okay, so Now this number, actually, we could have done it this way, or we could have used, if we still had this information from the beginning of that first problem, that the number of Facebook users is 2.45. Right? And if you add all these together, that would be 2.45. So this is 2.45 over 3.8. And as usual, well, as you have to get used to, a probability has to be a number less than or equal to 1. Okay? That's a number one type error students make. They think they get asked a question, what's the probability of event A? And they find the cardinality of A and 2.45, and they give that as their answer. They couldn't possibly be a probability, right? So a probability has to be a number less than or equal to 1. And this one turns out to be 0.6447. So I'm going to go out to 4 decimal places just because that way if I need to round to 3, I'll be able to do that. 0.6447, of course, on my math lab, whatever number of decimals they want, that's what you work to achieve, right? Okay, so that would be the probability of event A. We're picking a social media user and finding out that they are a Facebook user this month. Other type of questions that get asked are, what's the probability of not B, right? So not B is equal to the set of all users that don't use Instagram. Right, so there's what the English says or how the English questions gets asked using this dash, or sometimes in some books you'll see they'll use a little C for the complement of that set, or we'll read that dash as the complement of the set. So what's the probability of the complement of a set? Well, if we're trying to figure out what's the probability that a randomly picked user is going to fall within this green circle, that means that we need to exclude all those other counts. So that would be the same thing as taking 1, which is a total probability, minus the probability that they're just in B. All right, so if the probability of B computed in the same way, you can figure that out, right? Stop the video, figure that out. Are you getting that that's equal to 0.26, whoops, that's a 2, 0.2632? You should, rounded to 4 decimal places. So the probability of B complement would be 1 minus 0.2632, or 0.7638. Okay, so the probability that a social media user is not an Instagram user, 73.68%. Yes, so you have to remember how to convert from decimal to percentages as well. Okay. All right. We'll try one more of these using the addition rule. The probability of A union B. How about this? I'll pose the question now. You can think about it and pick it up and the answer in the second half. The probability of A union B, that's supposed to be equal to the probability that they're in A plus the probability that they're in B minus the probability of what set? Be right back.